Greetings to you once again. Welcome to Physics with Ben. This is the graph for the resistant box experiment I did. The video series where I tag the code as EPS1V3. Kindly click in the description box and then you will see the experiment on resistance box. So that video was not having the graph, and this is the video for the graph. So please click below the description box and watch everything about Ohm's Law, about potentiometer, about everything about current electricity. So without wasting more time, let's begin. I actually did a video for the graph, but the video was restricted. You can't see it right now. That's why I have to come back and redo the graph. You remember these values? Lovely. You may see this thing in the other video. So this is the graph. So this was the graph I plotted. If you have been following my videos and the pattern with which I've been plotting my graph, I am going to use the same pattern in this video to plot this graph. So for the sake of clarity, I am going to replot this graph so that you can see what it's all about. So let's start it all over again. Thank you. I'm going to make use of the values why I use another graph. These are the graphs I have plotted in the other videos. You can watch them and see what I did. This is a graph on knife edge experiments. So let's plot this particular graph. So we are asked from the question, if you have forgotten, quickly screenshot. This is a question. This is it. Question number 2. This is it. Good. Now they ask us to plot a graph of 1 all over V on the vertical axis. The graph of 1 all over V on the vertical axis, and then S on the horizontal axis. Good. So let's not waste more time. First things first. The graph of this against this. What are we supposed to do? Let us choose our scale. The graph of what? The graph of V inverse in both inverse against what? Against S. The graph of this versus what? S in ohm. So we are done with that. The next thing is to choose a scale for the graph. So for the y-axis, we say 4 cm. 4 cm to represent what? 1 unit. Good. For the x-axis, which is the s-axis, we say 2 cm to represent 2 units. Good. 2 cm to represent 2 units. Are we good? Yes, I think we are good. So, if you have been following my videos, you will not be strange. You will not be confused with what I'm trying to do right now. So let's start with this. This is the WAEC standard graph. From here to here, you have 2 cm. The graph is segmented to 2 cm. 1 cm means 5 small boxes. 2 cm means 10 small boxes. So let's count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are going to shift this graph because, as you can see, the maximum number here is 15. I mean, it's 4. Now the minimum is what? 2. So we are going to shift this line up a bit. Good. And then draw our horizontal line. Good. So we said 4 cm to 1 unit. So let's count. This is 4 cm. Write 1. Another 4 cm. You write 2. Another 4 cm. You write 3. Another 4 cm. You write 4. Another 4 cm. You write what? 5. So we draw our vertical line here. And you label this correctly or you'll be penalized. So this is V inverse slash volt inverse. All physics graph will always start from the origin. So this is 0, 0. It's what I'm doing. Lovely. Now, the next thing we are going to do is to put an arrow here. This is S slash ohm. Good. We said 2 cm to 2 units. 2 cm to 2 units. So this is 2. This is 4. This is 6. This is 8. This is 10. This is 12. This is 14. And this is what? 16. Good. 2, 4, 6, 8, 10, 12, 14, 16. That is the progression. Do you understand? Lovely. Now, the next thing to do is to find the value for each small box. I want you to know by this time, if you have been following my videos on plotting of graph, is that with this method, you can plot any graph. You see, we have stretched out, although the V inverse values are decimal values. But it interests you to know that we are going to plot it and you see everything included in the graph. So let's find the value for each small box here. So we're going to divide this one by 20 because 4 cm has 20 small boxes in it. So we say 1 divided by 20, and that will give us 0.05. That is the value for each small box on the vertical axis. So we say that 1 divided by 20, we have 0.05. This value will be used throughout the experiment. Lovely. So here we don't need to find the value for each one, but if you want to, you can still go ahead. So just say divide 2 by 10. 2 divided by 10. You have 0.2 on this axis. So here we have 2 divided by 10 will give us 0.2. That is the value for each small box on the horizontal axis. So the next thing we are going to do now is to plot the graph. We're going to start with 15. When S was 15, where is 15? 15 is halfway 14 and 16. That is it. So let's try. We have 0.2 times 10, 20, 30, 40, 15, 16. 10, 20, 30, 40, 50, 60, 70, 75. 25 will give you 4. That's 75. You're going to have 15. That is it. So 15 is halfway. So we'll count 5 more here. This is 1, 2, 3, 4, 5. This is where 15 is. So you trace 15 and where it meets 4. This is 4. Where it meets 4, that is where the point is. So this is 4. So this is the point. This is the first point. Good. So the next thing is when it was 12, it was 3.333. Now, divide everything here by what? By 0.05. By 0.05. When you do that, you are going to find the number of small boxes. The result you get stands for the number of small boxes you have to count before you get that particular value. So let's do it this way. We have 3.333 divided by 0.05. Divide by 0.05. That will give you 66.66. Round it up to 67. So let's count. This is 10, 20, 30, 40, 50, 60. Count more 7. 1, 2, 3, 4, 5, 6, 7. So you will trace this line. This is 12 against this. This is the line for 12. So where this line meets 12, that is where they intersect. This is a line. This is your 12. This is a point. So this is the second point. This is where they intersect. Good. What you see? That point is plotted correctly. The next thing is to plot when S was 10, V inverse was 2.857. So we say 2.857 divided by 0.05. That will give you 57.14. So just go with 57. You round it down. So we are going to count 57 small boxes to give us this exact figure, 2.857. So we'll have 10, 20, 30, 40, 50. Count more 7. 1, 2, 3, 4, 5, 6, 7. This is where that figure is. So you trace this line against 10. So where this line meets 10, that is where they intersect. So this is your 10. So this is the point. So they intersect at this point. A cross with a circle. That point is also plotted. The next point we want to plot is when it was 8, it was 2.5. Where is 2.5? Somewhere here. But let's verify. So we have 2.5 divided by 0.05. That will give us 50. So let's count. This is 10, 20, 30, 40, 50. I told you. So where 50 and 8 meet, this is 50. Where is 8? This is your 8. This is where 50 and 8 meet, this particular point here. This is where 50 and 8 intersect. That is that point for that. The next one is 6. Where it was 6 was 2.222. So we say 2.222 divided by 0.05. What do you have? 44.44. You just say 44, round it down. So we count. 1, this is 10, 20, 30, 40. Count more 4. 1, 2, 3, 4. So where 44 and 6 intersect. Where's your 6? This is your 6. This is your 6 here. Where they intersect is the point. That is where they intersect. You draw a straight. Yeah. The next one is 4. When it was 4, it was 2. We don't need to do anything about this one. When S was 4, V inverse was 2. Where's your 2? This is your 2 here. So 2 against 4. This is where 2 and 4 meet. So this is the point. The next thing is to draw your line of best fit. So let's do it together as I've been doing in the other videos. You go with this. 1, 2. This is not too good. Let's go with the first one and this one. Let's touch these points 1, 2, 3. So at this point will fall here, this one will fall this side. There's always a black sheep point in every experiment, so this last value is like a black sheep point. So we're going to touch the first point, we touch this one, we touch this one, so this will fall out, this to the left, below the line, and this will fall on top of the line. So this is out. Do you get? So we are touching at least 3 points. So you draw this line. Good. That is your graph. Lovely. You may screenshot. This is your graph. Perfect. Now, if they actually intersect, this is where the intercept is. You write change in C. That is where the intercept is. If you can look at this other graph, you can see something like this. I plotted this graph. I just want you to follow the procedure, then we're going to get back the same result. Good. So the next thing we want to do is to draw our line of our triangle. We are going to choose a point for the triangle. Let's choose this point. You have to draw a very big triangle. When a triangle is big, you minimize error in the experiment. So we're going to choose this point. So we draw a straight line here. Always draw a big triangle in all your graphs. The mark for the big triangle is 1 or half. So this is your big triangle. Good. That's your big triangle. So here is change in V inverse. Always write that. Here is change in S. So you trace this line. You trace this line so that you're able to read it from this end. You trace this line. Dot, 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 dot. You also trace this line here. Dot, 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 dot. When you do something like this, you are giving the WAEC examiner a marking guide. Yes, I know what I'm saying. You are going to come out. Mind you, your physics experiment carries 50 over 50, the highest marks. They are not divided. That is why I take it very upon me to do this video. Watch it to the end. So this point is your S2. Here is your S1. Here is your V inverse 2. Here is your V inverse 1. Good. So let's calculate quickly. Your slope, the slope of the graph is simply change in V inverse divided by change in what? S. This is the same thing as what? V inverse 2 minus V inverse 1 divided by S2 minus S1. If you substitute, what is your V inverse 1? Now, this is where the value for each small box will also help you. So we write 0.05, 0.05 times, let's count. This is 10, 20, 30, 40, 50, 60, 70, 80. 1, 2, 3, 4 times 84 times 84. The value there is 4.2. So your V inverse 2 is what? 4.2 minus what? V inverse 1. Your V inverse 1 for a different one which you don't know. So let's count. 0.05 times 10, 20, 30 times 30. What do you have? You have 1.5. 1.5. So divided by 16. This is a result of 16. Divided by 16. This is exactly on this point. So let's check. So this is 0.2. 0.2 times 0.2 times, let's count. 10. 1, 2, 3, 4, 5, 6 times 16. Times 16 you have 3.2. So minus what? 3.2. So if you do that correctly, what do you have? you have 4.2 minus 1.5, and that will give you 2.7 divided by what? 16 minus 3.2. That will give you 12.8. If you do that correctly, you have 2.7 divided by 12.8. That will give you 0.21094. What's the unit? What's the unit? That's it. So this is your slope. Let's see if it's the same thing with the old one. This was the one I plotted. So the same thing. But then this is not S, this is ohm. Good. We are done with that. The next thing they ask us to calculate, mind you, take note, this is your graph, screenshot. This is your graph, and this is your slope. Good. The next thing they ask us to calculate here is what? Determine the slope m of the graph. Determine the intercept. Good. The intercept on the graph, we write intercept change in C is given as what? Let's count. This is where the intercept is. This point. This point is the intercept. So we say 0.05 times. Let's count. 10, 1, 2, 3, 4, 5, 6, 7 times 17. You have 0.85. So you have 0.85 V. That is the intercept for the slope. This is the intercept. This is the point where it is. Good. Now the next thing they ask us to calculate is what? They ask us to evaluate the ratio E all over M. Evaluate the ratio E all over M. It means that this is also the same thing as their intercept. E, that E is also their intercept. It means that this value divided by what? By M, and that M is their slope. So this slope S is also equal to what? M. This is the slope. So we now write, for this we have what? Our slope is 0.21094 divide, sorry, that's not it. That's not it. Evaluate this. So we have intercept, which is this, we have 0.85 V inverse divided by what? 0.21094. If you do that, what you have 0.85 divided by 0.21094. This evaluation gives us 4.0296. Always leave your answers to 4 decimal or 3 decimal places. So this is this evaluation A all over M is equal to 4.0296. What's the unit? You have V inverse this time you have V square. You have V square ohm. That's what you have right now. V square ohm. I don't know if it's correct. You can help me check it for me. That's okay. Thank you. So the next thing we want to look at quickly is they ask you to state 2 precautions taken when performing this experiment. In electricity precautions experiments, you need to have what's called tight connection, or you're going to have what's called partial contact. And once you have partial contact, you're not going to have accurate reading. So how do you say it? I ensured tight connection during the experiment. Number 2, you were making use of ammeter or voltmeter in the reading. In the experiment. So what will you say? I avoided error due to parallax. when taking reading on the voltmeter. Mind you, what we used in that experiment was voltmeter. So you say, I avoided error due to parallax when taking reading on the voltmeter. That is that for that. The last one, which is the number 3, but you're asked to stay just 2. You say, I make sure I disconnected the battery when not taking reading to avoid drainage of the battery. Good. The next thing they ask us to look for here, state 2 conditions under which a piece of wire in a closed electrical circuit may not obey Ohm's law. If you observe very well, remember, Ohm's law states that provided the temperature and other physical conditions are kept constant, the current flowing through a conducting material is directly proportional to the potential difference at the terminus. Now, it means that if the temperature is not constant, the electrical wire will not obey Ohm's law. That's number 1. Number 2, if the length of the wire is not constant, the electrical wire will not obey Ohm's law. If you remember the potentiometer experiment, I told you, increase in the length of the wire will cause the resistance to increase. And once the resistance increases, the conductivity of the wire will also decrease, hence decrease in the electric current. Good. So, explain why the EMF of a cell is usually greater than the PD at its terminus when the cell is used to supply current in an external circuit. You can make research of this in your textbook. I must not answer everything here for you. Four identical cells, each of EMF E and internal resistance, are connected in series with a resistance R. Write down the formula for the current in the circuit. 2 marks. Simple. That is what those guys are looking for. From I is equals to E all over R plus R. This is the expression. Good. So you write. It means that since there are 4 EMF, you say your I is equal to what? 4E divided by 4R. No, the internal resistance of the cell will also be 4. So 4 times R, then plus R. This is simply the expression. To this, we have come to the end of this video and this class. Thank you for staying there with me. Don't forget to subscribe and share this video to those that need it. Share this video, comment, like, and share. Bye-bye. See you next time. God bless you.